This example comes out of section 2.2, the power rule. We've already seen that if we have a function like x to the 7, if we want the derivative of that, all we do is we bring the 7 out front, reduce the exponent by 1. It turns out that there's another rule called the constant multiple rule. I write down the constant multiple rule like this: if g of x equals a constant times f of x, then g prime of x equals the constant times f prime of x. It's actually a really simple rule. Basically, it says that if I do it with examples, if I have y equals 12x to the 4, and I say, what's the derivative of that? I say, well, it's going to be 12 times the derivative of this, which is 4x cubed. So 48x cubed is the answer. So if I do another example just to drive it home, if we have, y equals 7x to the 4 over 3, the derivative of that is going to be 7 times 4 over 3, so 28 over 3 times x. Take 1 away from the exponent and you get 1 over 3. So 28 thirds times x to the 1/3. Kind of a relatively straightforward rule, and it goes all the way back to the property of limits, which said that if you have a constant out front, all you do is you multiply that constant by whatever your limit answer was going to be. So an example that we could be asked here: what point or points on the hyperbola x times y equals 8 is the tangent line parallel to y equals negative 6x plus 7? Seems like there's a lot of information there, but if we change this xy equals 8 to y equals 8 over x, and maybe even better, 8 times x to minus 1, we can find the derivative. We can say, well, the derivative of this is negative 8x to the negative 2. Why is that useful? Well, the slope of the tangent line is equal to the value of the derivative of any point. We want to know when's it going to be parallel to this graph that they gave us. So in other words, when does it equal negative 6? When's the slope going to be negative 6? So I'm solving, when does negative 8x to the negative 2 equal negative 6? So when does x to the negative 2 equal negative 6 divided by negative 8 is 3/4. Now, x to the negative 2 is the same thing as 1 over x squared. So if you prefer that, that's a fine way to write it. And we could write this as x squared equals 4 over 3. So what does x equal? X equals either positive or negative the square root of 4/3. Better answer still, I suppose, positive or negative 2 over root 3, which even better than that, plus or minus 2 root 3 over 3, if we're rationalizing it. Now it says point, and so I suppose technically we would say, well, we need the coordinate, so y equals 8 over x from the original function, and so for one of the points I'd say y equals 8 divided by the square root of 4/3, and for the other one y equals 8 divided by negative square root of 4/3, and you could rationalize and find those a little bit nicer, but you get the idea here. If you're asked something about tangent lines, really what you're looking to do is find the derivative, and then in this case let that derivative equal negative 6 and solve. In this case we got some ugly numbers, but you get the idea of what the question's about.